Okay, rocking the residuals. Here we go. The correlation coefficient is not the only tool that statisticians use to analyze whether or not a line is a good model for the data. They also consider the residuals, which is a look at the difference between the observed value, the data, and the predicted value, the y value on the regression line. This sounds a little complicated, but it's not really. The residuals are just a way of thinking about how far away the data is from the regression line, as I'm sure you picked up in the con video we watched. So let's start with some data and create a scatter plot and graph the regression line that's been done for us. And in this case, the regression line is y is equal to 3x plus 6. Remember, the regression line is calculated for you either in the instructions, like on this problem, or in Desmos, okay? When you grab 2 points and calculate the slope and the y-intercept, that's just you writing an equation for the line. So if it says write an equation for the line, you use those skills. If it says regression line, use a computer or the instructions. Draw a line from each point to the regression line. Like the segments drawn from each point below. That also is done for you. The residuals are the lengths of the segments. How can you calculate the length of each segment to get the residuals? Well, you probably picked this up from the video, but basically the residual is equal to the actual take away the predicted. So the predicted is y equals 3x plus 6. That was it, right? Yeah. Or, the line of best fit. The actual is your real data. Problem number 2. Oops. Oh no. I did this task before I made the video, so let me, without giving away the answers. Anyway, that's what it's going to look like. Okay, generally if the data point is above the regression line, the residual is positive. So that would be, I'll use blue, positive residual. And if it is below the line, the residual is negative. There. Knowing this, use your plan from number 1 to create a table of residual values using each data point. Okay, here's how I want to do this. So, in your table, you're going to have your x value, and then you're going to have your actual y value, and then you're going to have your predicted y, which is your line of best fit, and then you're going to have your residual. Okay, so let's take this one at a time. So we're going to start with x equaling 1. So when x equals 1, what is our actual? Let's switch colors. Our actual is 10. So our actual is this dot right here. Now, what is the predicted? Candy question. How can we get that value right there without just like ballparking it, like, oh, it looks like 8 or 9. How might we do that? Well, what we're going to do is we are going to use our equation of that line, and we're going to plug 1 in right here. And 3 times 1 is 1. No, it's not. 3 times 1 is 3, and then 3 plus 6 is 9. And then you get your residual by subtracting 10 minus 9, and we get 1. Okay? So that is going to be equal to 1, which means it's 1 unit above the line. And then let's just go ahead and fill in the rest of the table. I might pause it here and let you guys work that. Well, I don't know. We'll see what I do in class. 2. So for 2, our actual was 13. And then our predicted, well, we have to put 2 here. And 2 times 3 is 6, plus 6 is 12. So we have another 1. And then we have 3. Now for 3, this one goes down. And I can't tell exactly from looking there. So remember, it's in the table up here. And 3 is 7. So 3 is 7. And our predicted, well, we have to plug in 3 now. I'm just going to put a big star up here because we're going to keep coming back to that. And 3 times 3 is 9, plus 6 is 15. And 7 minus 15 is negative 8. It's our first negative. It's the first time we've rocked a negative residual. 4, let's go up to the table and grab what 4 is. It looks like it is 22. And we got to plug in 4, and we get 18. Therefore, our subtraction is 4 above the line. And 5 is 28. And we plug in 5, and we get 21. And that one was way above the line. It was 7. And then 6, actual is 19. And 3 times 6 plus 6 is 24. And 19 minus 24 is negative 5. Here's our answer to number 2. Now, it was my experience last year that everyone understood that, and it's on the test. But on the test, this is the question that they forgot how to do, okay? So we're going to take our data, and now, number 3, statisticians like to look at graphs of residuals to judge their regression lines. So you can get a chance to do it. Graph your residuals here. Here is a graph of our residuals. So for x equaling 1, was it above the line or below the line? Well, it was 1 above. So when you do this whole new thing that people forgot last year, this line is your x, and this line is your y. So we go 1 over, and then we would go 1 up. Okay, so that means when x was 1, the actual data was a little above the line. 2 is also 1. Now 3 was below, right? What was it? It was 8 below. So it's going to be 3 over and 8 down. 4 was 4 above. 5 was 7 above. And 6 was 5 below. Okay, there's our residual graph. I'll pause it here in case you guys don't have it. Now you've constructed a residual plot. Think about what the residuals mean and answer the following questions. Okay, I'll lay out your name to the candy list if you can get these. If a residual is large and negative, what does that mean? Ideas? Well, that would mean that the actual data is below the regression line. What does it mean if your residual is equal to 0? Guesses? That means that the regression line intersects the actual data. 6. If I told someone, or if I told you that they estimated a line of best fit for a set of data points, and all the residuals were positive, what would you say to them? I think that these are pretty familiar, or pretty similar to the test, so I would definitely listen up here. Well, that would mean that they estimated not a period, that they estimated the line of best fit too low. So it must be below all the actual data points is another answer. 7. If a correlation coefficient for a data set is equal to 1, what would the residual plot look like? Well, there wouldn't be any residuals because the data will all fall in the line. So this is called, it would be perfect correlation. And it would look, the residual plot would be like, okay, x is 1, 2, 3, 4, and 5, 6. Wait, how did it look again up here? Oh, it was kind of more down the middle. So, remember it went this way too, and then you had the points that were above, then you had points that were like below. So where would the dots be if it was perfect correlation? Like so. Statisticians use residual plots to see if there are patterns in data that are not predicted by the model. What patterns can you identify in the residual plots that might indicate the regression line is not a good model for the data? Based on the residual plot, are there any points that may be considered outliers? Ooh, okay, what do you guys think about number 8? How about this one? So, this residual plot shows a pattern of increasing residuals, which means the linear regression is a better fit at the beginning than it is at the end. There may be some other factors causing the spread in the residuals that is not accounted for within the linear model. I'm not going to write all that. I'll let you guys sum it up in your own words, but I'll read the important part of it again. This residual plot shows a pattern of increasing residuals, which means the linear regression line is a better fit at the beginning than it is at the end. So if you picture your line of best fit, in here, the dots are pretty close to the line. But once they start getting out here and it starts getting bigger, they're farther away from the line. So it's a good model for low x values. What do you guys think about 9? We got this weird thing going on like that. What does this mean for our residual plot? Again, I'm not going to write it. I'll let you sum it up in your own words if you already haven't. But the curved pattern in the residuals suggests that some other model, possibly quadratic, a little foreshadowing for next year, would be a better fit than a line. So remember, a quadratic, I'm just trying to think of what this would look like. So you have some points here that are below and then points that are above. So might be like that, where you have some below and some above. And then this suggests quadratic or exponential possibly. 10, what do you guys think about 10? Here's the answer. The residuals alternate from positive to negative each time, suggesting that a linear model might be missing some pattern in this data. So there's a pattern, it just might not be a linear pattern. What do you think about 11? The residual plot shows an outlier of 10, but the residual plot is distributed in a relatively random way that suggests that the linear model is pretty good. So remember, it's good if what? It's good if there's about the same amount of dots above as below, but that one is an outlier. Okay, that is our task for today. You're welcome. I have done most of that for you. So what I want to do now is we are going to do, I'm thinking of getting rid of, I'm not going to totally get rid of the ready because we really have to work on the, this isn't too hard though. This doesn't make you do any box. I thought it was going to have you do box plots. This is just reading box plots, so that's simple. It's the set corresponding to what we did today. Okay, so you're just going to graph those residuals there now, and then interpret like we just did. And then here, I want you to do these. It's okay if you don't finish this today. But if you get this far, we do have to have this done by the time you hand in the module, and that's coming soon. We're on 9.8 today. We didn't spend a ton of time on constructions, so I want to make sure that you know how to do them. I have a couple you can borrow if you guys need to. But finish up the ready, finish up the set, and then maybe I'll have a fun thing or two that you guys can do on the board when you're done. And that will be a Friday. Thank you.